Hey, welcome to FlimDog Tutorials. Today we're going to be looking at molar conversions. So molar conversions. Let me know what your questions are and topics you need help with, and we can figure those out together. So molar conversions, the one I thought that we could do, if you'd like another practice with molar conversions, you can check out, we've got a video on this here, 73.6 grams of cesium bromide to moles of cesium bromide. But let's check out this one. This is a more challenging topic, I think, for a lot of folks. If we're going to go from grams over here to particles of magnesium phosphate. So let's try that. We'll write down what we have, 936 grams of magnesium 3 phosphates. There's three, it's not magnesium 3, it's just magnesium phosphate. And we're trying to get to some amount of particles of our magnesium phosphates. All right, so step one, whenever you're doing these, is finding the molar mass. And if you'd like practice with the molar mass, there's some videos that we've done that you can check out on that. But let's find the molar mass here. We have 3 of these, so I'm just going to write down 3. And we need to find the molar mass of magnesium. So magnesium, we'll need our periodic table. Magnesium right here, the top number is the atomic number. That's the number of protons. The bottom number, the bigger number of the two, if it's switched, is your molar mass. So let's write down 24.3. 24.3. Sorry, this pen is not great. 24.3 there. And plus, let me switch out my pen. Sorry about that. Get my purple. Now we need to find phosphate. Now the thing about phosphate is we have 2 phosphates, so I'm going to put a 2 right there. And first let's find our phosphorus. So phosphorus is 30.97, which we can round to 31.0. So 31.0. And then we have 4 oxygens, so this is going to be 4 times whatever oxygen is. And if we find oxygen, it's one that we use quite a bit, 16. It's 15.999, but let's round that to 16.0. So we'll round that to 16.0 here. And we already noted that we have 2 of this whole phosphate. So this represents phosphate. Let's plug that in and see what we get in terms of the molar mass. So 24.3 times 3, 72.9. Jot that down. In case I make an error, you can know where I made my error. 72.9, and then the other piece here, we have 31 plus 4 times 16 equals 95, times that by 2, there's 190. So plus 190, let's add our 2 numbers together, plus 72.9, gives us 262.9, so you get the same thing. And that is units of grams per mole. So this for me is always my step 1, is to find the molar mass of whatever it is. Step 2, when I'm doing molar conversions here, is to write out what this actually means. And this means I have 262.9 grams when I have 1 mole, and 1 mole is when I have 6.02, I guess I'm done with my calculator, 6.02 times 10 to the 23rd, and in this case, I'll just write it down, magnesium 3, magnesium phosphates. Okay, so I have 262.9 grams when I have 1 mole, which means I have this many of them. The really big clarification that I think is confusing is one of these does not weigh 262.9. You need a ton of them, and not just 2,000 ton, you need 6.02 times 10 to the 23rd of these in order to be 262.9 grams. Okay, so how does this work now? We have a number that they gave us, 936 grams. My step 3 is always take whatever I was given, and as you get more comfortable, this might actually become your step 1, your 936 grams, and put that over 1. Then I put in some placeholders, and I can actually do this in one step, so I just put 1 in, and I put the unit that I'm going to. In this case, we're going to particles. The numbers that come with this 6.02 times 10 to the 23rd, the things you'll see quite a bit in chemistry, I'll just jot a few down here. You'll see this referred to as sometimes atoms that you'll be looking for, molecules, ionic compounds, or just compounds. Sometimes you'll see representative particles. So there's various things, but usually that's what the 6.02, those are keywords for when you're looking for 6.02 times 10 to the 23rd. All right, so we put what we have over 1. We put where we're going. We're going to particles. In this case, we just said this 6.02 times 10 to the 23rd is the particles number. So I'll put that down right here. So after I've done that, I need to cancel my grams, and the way that I do that is using step 2 here. So my step 2 really becomes my money. These are my conversion factors. So I'm going to cancel grams, and if you cancel grams, do you put it on the top or the bottom? When things are on the bottom and top, they cancel. So I'm going to put grams right there. And on the top, what I need to do is get where I'm going. So we're going to particles, so I'm going to put part for particles on the top. Then I refer back to my conversion statement that I made here based on my molar mass, and I say, what is the number in front of grams? And it's 262.9. And the number in front of particles is 6.02 times 10 to the 23rd. Now let's plug that in. We're going to multiply the top, and then we'll just kind of put a line over it and then divide by this bottom one. 1 times anything is the same number, so you can sort of ignore that 1. Let's plug that in and see what we get. A really common problem is being able to do this and not actually put it in the calculator. So let's see how we put that in the calculator. I won't use the EE button. I don't like it, but it is a good one to know how to use. 936 times, and then I'm going to do 6.02 times 10 to the, my exponent, 23, and then close my parenthesis. And it's really important you do that, or your answer will be wrong a very high percentage of the time if you're not sure what you're doing. So I'm going to enter this. I have a number that I got right there. And now I'm going to save that number by just pushing divide. So my calculator saved all of that. Now I'm going to divide by 262.9. And we got 2.1 times 10 to the 24th. 2.1 times 10 to the 24th. And that is my number of particles of Mg3 PO4 2. Now, I won't get into it right now, but you will have, depending on your level, you'll have times where they ask, well, how many atoms of magnesium is that? So to find the number of magnesiums that this is, you would need to multiply this to find, well, I guess I am going to get into it right now. If you wanted to find your number of magnesiums, you would multiply this number times 3. And if you wanted to find out your number of, say, oxygens, we have 4 oxygens 2 times, so that's 8. You would take your oxygens times 8. So it'd be this number times how many oxygens we have, and that's 8. And if you wanted to find out how many, say, phosphorus you have 2 phosphoruses there. So it would be this many particles that you have times 2. So phosphorus would be that times 2. And so every now and again, they'll ask you the number of actual atoms you have of each thing. And that would be your next step. I won't type those in, but you would do 2.1 times 10 to the 24th times 3 for magnesium, 2.1 times 10 to the 24th times 8 for oxygen, and then for phosphorus there, 2.1 times 10 to the 24th times 2. And that will get you all those. I hope that's helpful. Let me know any questions that you have, and we can totally figure out chemistry together. And it's actually pretty fun when you get rolling on these. There's an easier flow chart you can use, but I think this is a better way to learn. If you want to see an easy flow chart, maybe I'll make that sometime for you also. And that gives you a nice double check of what to do. So check that out. See you soon.
Wonder, oh wonder, Phlegm.